What we're going to do here in section 6 is look at the three-dimensional coordinate axis, and this has been kind of short titled also the right-hand frame. There's a couple different ways that you can look at the coordinate axis, and we're going to use kind of the right-hand frame one, which means if you take your right hand and curl your fingers towards you and point your thumb up, that you will develop from the positive x to positive y with your hand, and you'll develop the positive z with your thumb. So this is the coordinate right axis, and all these different ways to locate the coordinate planes, okay? And now that you're going to deal with a coordinate, we're going to deal with all the coordinates in x, y, z. So, you know, if you're going to map out a specific spot, we need to know all three pieces. The origin will still be at 0, 0, 0. And now you have octants now instead of quadrants, because there's going to be different ways to look at something. So I've got this box here to kind of shape you up into looking at things. And if you look kind of down here towards the bottom, and I'll kind of shade it in purple, I don't know if you can see, on this paneling right here, this would be the XY plane, okay, because we're down on the x and y axis, and all of the z coordinates are 0. Once you come over here to this guy right here on the kind of the back side, I guess, as we look at it, this part back here, this is the y, let's see, the YZ plane. All of the x coordinates are 0. And if you look right here, this is going to be the XZ plane. All of the y coordinates are zeros. So use your imagination a little bit. I think you can maybe see the different planes there. But the 3D systems are really fun to mess with, and we're going to look at a few different ways to find midpoints and distances and find points with the 3D coordinate system. So let's say I want to plot the point. You know, what if I've been given the instruction to plot the point 235? Well, when we're doing this, we're looking at x, y, and z. So we just need to draw our coordinate axis system. Here's the positive z, straight up. Here's x running positive x is going to run diagonally to the left. So here's x. And positive y is going to run diagonally to the right. So this is the positive y. And if I need to find the point 235, I need to find the point 2, which is going to be on the x-axis 2, the point 3, which is on the y-axis 3. So if I'm looking at just those two guys, then where they intersect, that's the point 2, 3. But I also need now my third dimension, the third dimension, z. So 1, 2, 3, 4, 5. So somewhere right straight up. So 2, 3, 5, somewhere right around in here is the point 2, 3, 5. Alright, and when you work with three-dimensional coordinate axes, you can do the same things that you did when you were working with just x and y. You can still find distance and midpoint. And the formulas are exactly the same now, except instead of looking for differences between just x and just y, we're now going to look for those same things between x, y, and z. So the formulas themselves don't change at all, but they do increase with one more step of layering, I guess, basically, of items. So here we're going to go with the 3D coordinate axis system again. And here's z, here's x, here's y. And what we're going to do is we're just going to plot the point negative 2, 3, 1. So negatives then are going to go away from us on the board, and we're going to have something that would look like this. Okay, and so if I'm at the point negative 2, 3, 1, then what I'm going to do is I'm going to go negative 2 in the x direction. I'm going to go 3 in the y direction. And then I'm going to go up to 1 in the z direction. So somewhere right around in here is the point negative 2, 3, and 1. The point 4, negative 1, 5 then would be 4, 1, 2, 3, 4, negative 1, which would be this way, and then 5, which is going to be up 1, 2, 3, 4, 5. So somewhere right around in here. And that's not on the y-axis. Now that's above it. So this is the point negative 2 or 4, 5, negative 1, and 5. And what I want to do is I want to find the distance. I want to find this distance right here between these two guys. Woo. Okay. And so the way to find the distance then is to just use my distance formula. And the distance formula doesn't change from what you've already done previously. It's going to be the square root of, and then I'm going to have in there x minus x, and the order needs to stay the same. So negative 2 minus 4 squared plus y minus y, 3 minus negative 1 squared, plus, and then z minus z is 1 minus 5 squared. And we're just going to work all these guys out. Well, this is going to be negative 6, this is going to be 4, this is going to be negative 4. So when you square all these things out, you end up with 36 plus 16 plus 16. So here's your square rooting. And I'm comfortable if you just add those guys up and leave it alone. Square root of 68, I'm fine with that. If you are absolutely insistent on a decimal answer, that's fine. Remember, this is an approximation, and we would just carry it out a couple decimal places, 8.25. Okay? Not hard. The same thing with midpoint then. So if this is distance, midpoint's the same thing, except now I need 3 points instead of just the 2. So I'm going to add the x-coordinates up and divide by 2. Negative 2 plus 4 divided by 2. That's x. Y. 3 plus negative 1 divided by 2. That's your y. And then 1 minus 5 divided by 2. I'm sorry, 1 plus 5 divided by 2. There's your z. And these guys will all come out. And again, if they're fractions, leave them at fractions. If they're not, they're not. That's fine. But I'm going to end up with a 2 here, a 4 here, and a 6 here. So this looks like it's going to be, whoops, this is a 2. It's going to be the point 1, 1, 3 for your midpoint. Alright, another really cool thing that you can do is graph a sphere, or at least come up with the equation of a sphere. Sometimes graphing them can be really challenging in 3D, but we can come up with an equation of a sphere. And just like with a circle, it's just going to be the x-coordinate squared, the y-coordinate squared, and the z-coordinate squared equals radius squared. So it really isn't too different from the things that you've already talked about. So with circles. So anyway, just to show you how this is done, we're going to look at an equation of a sphere with centered at 2, 0, negative 3, and a radius of 7. And this really is as simple as substituting in 2, 0, and 3 for h, k, and l. And so what that's going to end up with is x minus 2 squared plus y minus 0 squared plus z plus 3 squared equals 49. It really is that easy. Now, if you wanted to go gangbusters and graph that guy, then we would need our 3D axis. And we need to find that center. So that center's at the point 2, 1, 2, 0, and then negative 3. So we're going to come down And remember, these dotted lines are going to represent the negative parts of our axis. So 2 and then -3 down. So I'm here at 2 and I'm down 1, 2, 3. So here's my center. The radius is 7. So from here I'm going to come up 4, so somewhere right around in here. I'm going to go down 4, so somewhere right around in here. I'm going to go this direction 7. So if this is 2, 7 would be quite a long ways. And then again out to about 9. So you know, it's going to look something like this. Here's the top part of my sphere. Here's the bottom part of my sphere. Ooh, it looks like an ellipse. So there's the bottom part, and it would curve around this way and back around that way. That was not very pretty, but not bad. I think you can kind of get the idea. It's a little squished, but there you go. There's how you can do a sphere in 3D.